Hi friends, here in this video I am going to draw the isometric projection of these two solids. One is the rectangular prism, over that a tetrahedron is placed centrally. Here for the rectangular prism the length is 80 mm, width is 60 mm and thickness is 20 mm. So let's draw this one first. Later we are going to draw the tetrahedron over this one. So let's start here. So starting this point here, in this direction I am using the 60 mm length, angle 30, and in this direction the length I am using 80 mm, enter, and 150 is the angle, and opposite edges are same, 60 mm length and angle is 150 degree. Finally length is 80 mm and angle is minus 30. Now the thickness we need to set for this one. For that I am using the move option. Select this one, pick any one of the corner, lift it. X movement is 0 and in the Y axis 20 mm I am going to enter. Visible edges I am going to draw here. This can also I can connect, but I don't want to keep the hidden elements here. These also I am going to remove. Just use the trim option and just remove this one. So over the top surface of this one, this solid, a tetrahedron is placed. So to place the tetrahedron, first thing we here in the question only side length of the tetrahedron is given, axis height is not given. So that we need to find the axis height by drawing this view. Front view and top view we need to draw and find the axis height of this one. Also this solid is placed on the top surface of the rectangular prism, so that here I am going to find the center point of this rectangular prism. For that here simply because this is not equal side uh, box here, so for that the vertical and horizontal lines cannot be used to find the center point. Here instead of that one we are going to use, we are just connecting the opposite edges with the midpoint like this. So by this we are able to find the center. Now the tetrahedron we need to draw. To find the axis height of the tetrahedron, so tetrahedron in the sense all the four surfaces of the solid are triangular in nature. So from in the top view a triangular we are going to see, triangle we are going to see whose side is 45 mm. For that I will construct a triangle first here. I'm going to draw the front view, top view. We know that how to construct a equilateral triangle. Equal command we can use. One side we are setting for the respective length and we are making equal like this. Now its front view I want to draw. For that let me project this one. So here because this is the solid here, the apex we need to show. So for that we can find the apex simply uh, medians, where if you draw we can able to generate the apex point of this tetrahedron. Unwanted lines we can remove. This is what. Then text command, if you want you can give the names also here. Say this is A, this is B, this is C, and this is, let's say, O. O01 in fact you can write. the axis O1. Now all these points I am going to project here. Okay, so here this is what B in bracket A, this is O1, and this is C. So here, in order to get the axis height here, axis height is not given. So that exercise we can find. We know that the edge length of this tetrahedron is 45. So here simply what I will do, I will draw a axis line here like this. So this axis line I am going to cut with the true length of the edge length of the tetrahedron. So here the edge we can see here, uh, O1C is perfectly parallel to the VP, so that in the front view the true length of 45 mm we can see O1C. So for that what I will do, I will take the arc by center point, C as center, and radius is equal to 45. This axis I am going to cut. Then just remove all the lines here like this. So in this way the axis height we are going to get for the solid. That is, this is the true length of the slant edge which is connecting with C, from C to O1, and axis length we can find by cutting this like this. This is what the axis height. So the same thing I got here. We can see the true length 45, which is parallel to the slant edge CO1 parallel to the VP. So in the front view, the parallel line, which is the parallel length, we are observing as the true length of the slant edge. So by that we can able to find the axis height here. From the figure also we can see 36.74. The same thing I got here. Now this one simultaneously we can generate this solid over this one, or separately we can create and assemble. So in this one more condition is given. What is that? The axis collinearity is there, of course. Apart from that, here the edges of the both the solids are parallel to, at least one of the edges of the both the solids are parallel to VP. So here this edge and this edge are parallel. So in this fashion we need to draw that one. What I will do, so this one I am fixing into a box first. So let me construct a box here. And the length of this box I am measuring and keeping here for the isometric drawing. So that means a rectangle is created here, 45 into 38. So this edge I want this side, means this edge I have to draw this side. So I will start from this one, this side 38.97 edge length of this box. I'm considering this surrounding box of this tetrahedron. So let's take the line here. I will construct here in the 30-degree direction. First length is 38.97. Enter. Angle is 30 degree. Now this length is 45. Opposite edges are equal here. this side 45, enter, angle is 150. Again opposite to this one, the same length is coming 38.97, this side 38.97, enter, angle is minus 150 degree, press the enter button, and finally the last that is 45 into 30 minus 30 degree, that is opposite edge we got like this. So after constructing this one here, it's very simple because these ends are the corners of the base of this tetrahedron, ends of this box, and center point of the this rectangular box is the third corner of the base of the solid. So I'm taking the construction line or visible line here. This is my A, this is my A, this is B, and C is exactly to the midpoint. So directly I can use the midpoint and connect like this. After doing this one, the height of the solid I found here, axis height I found by using this method just now shown. So here, to locate the height here, the center point I need to find here. Once again, the type of isometric box is rectangle here. For that, I need to use the midpoint joining method to find the center. Okay, from this I got the center. Now I can take the center line from this center in the vertical direction. What is the height? 36.74. 36.74, enter, angle is 90 degree. So this is the height of the solid. Now connect all the visible slant edges of the tetrahedron solid here. This one as well. Right, the solid is created. So here this one I have to bring here. I have to bring over the rectangular prism, and I have to make sure that at least one of the edges of both the solids parallel to VP. So that condition I need to satisfy. What I will do, I'm going to take the move option now. So this entire solid I am selecting, then of the copy original I want to move. So pick from the center. So already a center is created here, and align to that center point once again like this. Now what is left here, the hidden portions we can remove. So just zoom out this area. So hidden elements, this is the hidden element, just remove this one. Here is the hidden element. Right, so this is how the isometric projection is view is done here. So here I used the true lengths here. This is the length, this is the width, this is the thickness, and axis height of the solid. This is the axis height of the solid, and the edge length of the solid. One of the edge length I can show here. Let me place here. Right now, so all these are true lengths. By using true length I have drawn. So whenever you are drawing it, the isometric view or isometric drawing you are doing with the true length, that one is called the isometric view. If you convert that one into isometric scale, that one is called the isometric projection. So let's convert this one into isometric projection. For that, go to the scale, select the entire combination, then scale factor I need to enter here 0.815. Press the enter button and place this one like this. So now dimensions have been changed here, you can see. So these one we can edit and show. So this is what the length we have. So for that, removing this one and entering this one as ISO 80 mm, and this one once again removing, and this one we can enter as ISO 60 mm. This one is ISO 20 mm, and this one tetrahedron base side length is 45. So that one we can enter ISO 45, and axis height we found here, which is also ISO 36.74. We supposed to enter here ISO 36.74 mm. So that's it, guys. This is how the combination of these two solids we can draw into isometric view and isometric projection. Hope you like this video. Please do share the video and subscribe to my channel, so that I can bring more number of videos like this. If you have any doubts, any comments, you can put into the comment box. Thank you.